discuss. It's a model context protocol. So let's discuss about this one. So before model context protocol, let's see what are LLM applications. Nowadays we are talking about LLMs, right? So how LLM application works. So what is MCP and MCP high level architecture, how it works. Maybe we'll compare with MCP with API. And if time permits, maybe we'll take a demo today. Okay. Yeah, before starting my session, any questions from your side? Okay. Let's take, let's see what are LLM applications. So we normally discussing about web applications, right? Desktop applications, mobile applications. So all are software applications only. But so desktop application, there is a separate meaning. Web application, there is separate meaning. Mobile applications, so maybe architecture is different, a different meaning. So like that. So going forward, we are so maybe we'll commonly use LLM applications. So like how we are using nowadays mobile applications, maybe we are going to use LLM applications as well. Let's see what are LLM applications. Any app that depends on LLM for core functionality is so considered as a LLM application. So any application, if it is involves LLM large language model, so as their core functionality, like let's say we are regularly using ChatGPT. So ChatGPT is a web app, right? You have a web app and we have a mobile app as well. So internally, it is going to use LLM. So that maybe we can call as LLM application. Yeah, of course, it's a mobile application, but internally it is using LLMs. So that we can say is a LLM application. Yeah. Any question? Yeah, LLM is basically large language model. Yeah. Any functional. Let's say you developed application for chatbot. Okay, for chatting, if you are using LLM, that is a LLM application. Okay, so anything, let's say request response kind of thing, or mm, your functionality. See, all are, let's take mobile applications, right? Mobile, yeah, that's a business requirement. Let's say for Rapido. Rapido is a mobile app, right? That's having their core functionalities, booking cabs or vehicles, like that. So phone pay is basically payment or financial app. Yeah, yeah. That we can call as a core functionality. Okay, core or basic functionality, you can say. Copilot. Copilot is also LLM. It's a kind of LLM. Okay. So for using that Copilot, maybe you're using tools like browser or mobile app, right? Yeah, web app could be one LLM app. Okay. So here in all these LLMs, let's say, so for these LLMs, there are different things. One is a generative AI based. Okay. So that let's see what is generative AI. So generative AI is basically content creation. Okay, so that content could be text, image, video, audio, so the kind of thing. It's basically reactive. So that generative AI applications are a reactive. It takes the input, basically prompt, we call it as a prompt, and gives the result. Okay, so in ChatGPT, right? Let's say if you ask a question, you'll get the response, and if you're not happy with that response, again we need to ask question, right? It's a conversation kind of. So for every prompt, maybe there is a human interaction. So those kind of things are called reactive so things. Okay, is part of generative AI. So some of the examples are ChatGPT, Copilot. Okay, So use cases for this generative AI is summarizing the text, maybe 10 pages, 20 pages, generating a logo from a given text. Okay, these are the common use cases for generative AI. So now we got right. You are normally using these things: Copilot, ChatGPT. All these are generative AI LLM applications. Okay. So the main thing is it creates a content immediately. Basically, if you ask a question, it generates a content and it shows you, right? So these kind of things we'll call as a generative AI. Any questions here? Yeah, so maybe that word may be not familiar for us, but we started using generative AI applications, ChatGPT, Copilot, Gemini, all these things are comes under generative AI content, okay, applications. Let's see another one. So another kind of LLM application is agentic AI. Okay, so generative AI and agentic AI. So in agentic AI, it that app itself takes a decision and it acts accordingly. Okay, so that will call as autonomous. So this is a kind of proactive. Okay, and it's not a reactive; it's a proactive. It takes a prompt, takes the decisions if required, and gives the final result. Okay, so proactive basically takes the question and so try to find out the solution. If any decision is required, it will take automatically. Okay. So some of the examples maybe Devin AI. I think it's one of first AI-based software developer. See, software developer. It writes the code, tests it, debugs it, do everything. Okay, so like that, baby AGI, it's basically artificial generative intelligence. Okay, so the use cases for this is let's say you can ask a question like plan a 3-day trip to Goa, including hotels and flights, right? So here we are giving a task. So basing on this prompt, it will take the decisions. So which hotel we can take, which flight we can take. Okay, so 3-day trip by which route, all these decisions it will take automatically. Or something like book a dinner for a team at BBQ today. Okay, so here it involves multiple steps. So for booking a dinner, we need to check team availability. So we'll get the calendar information from the team members. It checks the BBQ availability, other stuff. So these are the decisions it will take automatically. Okay, so this is basically achieve a goal. So for me, okay, basically achieve a goal. So goal means having a subtask, right? So for dinner, so at which restaurant and with whom. So all the calendar details, BBK, restaurant availability, all the stuff. So there is another one called AI agent. Okay, so AI agent is basically a part of agentic AI. So agentic is a big system. It involves multiple modules. Each module is a AI agent again. Okay. Any questions here? Okay. So let's proceed then. So we are talking about LLMs, all the stuff, right? Here, so we are basically using LLMs. So till now, we did not do any training information, applying them at ML models, all the stuff. No. So LLM applications basically we are going to use LLM and try to create a workflow. Okay, we try to create a system that achieves a particular goal. Okay, let's see how LLM works. So I just draw a picture. Let's see one way. So let's say we are the user. and user sends a prompt to LLM. So that is a prompt basically. So let's compare this with Chat GPT, right? So you are opening an app, mobile app or web app. You are just typing, and the text is going to LLM, and the LLM is responding. Respond. This is the core functionality. It takes the input and gives the response. This is what so any LLM application
Hello?
is. Yeah,
With the confirmation you are saying.
Gauri, you're asking question.
No, Chandu, no.
Okay, fine. So this is how so any LLM basic LLM flow. So user sends a prompt that is basically input, get the response. Okay, so this is normal thing. So with this thing, let's say we got a response, right? Let's say you're asking a question, you got the response. So from where that response is coming, do we really know? When you are using a chat GPT, you're asking information, right? We don't know about the source of the information. Am I correct? Guys, can you respond? Yeah, so source, because you're asking a question, let's say yesterday I submitted a tax returns. I asked Chat GPT, and I got the response of the some procedure sequence of steps. I got the steps. Okay, so but how LLM got that information? What is the source of that information for LLM? Whether it is a reliable source, so how it is coming, we don't know, right?
Yes.
Yeah, so because from which website it referred, which books it referred, all the stuff we don't know. It's completely black box for us. That is one. Yeah, and and we are not sure whether the information whatever LLM is giving is updated or not. Right? We don't know about that. And we are also not sure whether it is connecting to external systems or it is having its own data, knowledge base, or library. We're not sure. And it is not taking any actions. It just takes the text and gives the response. And one more thing is, it is not having any memory. Okay, LLM is not having any memory. It just takes the input, analyzes it, and return it back. Let's say after 1 month, if you ask the same question, okay, it will not remember that. Okay, that is one of the basic LLM problem. Okay, so these are the major points. So if you are thinking about LLM application, these are the major points we need to consider. Okay, so let's see how we so solve this kind of issues. Remembering, so memory, whether it is storing or doesn't matter, but the thing is that it won't recollect the information. Let's say you have a chat GPT, you are asking frequently asking questions, right? So let's say you asked one question in 1 month back. If you ask the question again, it will not remember that 1 month back question. Okay, again it will treat it as a new one. Okay, so that is what basically memory here. So remembering that past history, maybe you can say the past history. Okay, so yeah, so basic functionality is that one, but in that these are the key concerns. Let's take one by one. Source, basically we don't know about. See, yeah, in the public information is fine, but if you want to have a references, we will not get that. Okay, so that is where comes. So if you want to take the source, you can go to another system. Okay, so that is we can integrate that external system to the LLM and get the source from that. Okay, so that source basically contains that we'll call as a knowledge base. That knowledge base have a docs. From the doc we can get the response. Okay. That system is called RAG. Okay, you might have heard about RAG systems, right? Retrieval Augmented Generation. So this is the real-time use case for corporate companies. LLM is basically trained on public data. Okay, so if you use that documents to the LLM, you may not get accurate information because that's not trained on that. Each company is having their own policy documents, project documents, sensitive information, all the stuff. So if you want information from that source, so now we have a source. You can use a RAG functionality and integrate these documents into a knowledge base. You get the information from that source and pass that information to LLM, and LLM will respond. Here we can eliminate a source concern, right? So now we can pass the source. Hey, get the information from this website, get the information from this document. Okay, any questions here, guys? Are you following? Okay, so here let's say in a company, you have a let's say 10,000 documents. You updated in a document form some that will normally call as in a vector database. For now, just consider that is a knowledge base. Okay, so that company documents frequently updates, right? So every 3 months, maybe policy will change or some new policies will come. That also we need to update, right? That is a updated information. If you're not updating, that becomes a old data, right? So whenever you want updated information, you just upload knowledge base. You just upload documents here in a RAG system. So you no need to change anything. You just update this in a RAG system. That is basically database. That whenever you update that, see this blue color. Whenever you update a new documents, again you'll get the updated information. Okay. So this is how we can solve the second point of updated information. You can provide external knowledge base and you can update the knowledge base regularly. You can get the updated information. So next, how about connecting external systems? Like let's say in a corporate world, so we'll have a lot of systems, right? Multiple systems. So how do you integrate with external systems? Okay, so let's say so that could be in third party services or could be in cloud, all the stuff. So there comes MCP, Model Context Protocol. Using this Model Context Protocol, we can connect with the external systems. See why I am talking about Model Context Protocol now. It's almost similar to APIs. When you want to connect with external systems, you always use APIs, right? Currently existing architecture. So whereas LLM applications, we use MCP. Okay, so using this MCP, we can
Chindu,
connect.
here for RAG interaction, we no need API calls. That, yeah, directly we can interact with RAG, whatever you.
So RAG, so because that's a within a system, normally that
Oh, okay.
so because that is a sensitive data, our corporate data, right? That we should not keep in a external source.
Uh-huh.
Okay, so that is within a system, right? So so let's take a DB call. So for DB call is like we are going to connect to the database, right? So something like that, yeah. So but if it is an external system, maybe yeah, you can go for APIs. But for that we don't need a MCP all the stuff because we are going to connect to the knowledge base. Okay, so that could be database or documents, any stuff. Okay, that's all in within our system.
Okay.
Okay. No, so it's not part of LLM system. LLM is a model. Okay, RAG is a concept. Okay, to refer external source and apply that to LLM. Let's take one scenario. If you remember in the initial days of Chat GPT, when you ask a question, if it doesn't know, it just used to reply saying that I don't know about this information. I trained until this date. Okay. So now it is not getting that message, but it is getting looking or searching in internet or searching in some other links. So if you can observe that. So basically the kind of RAG, because earlier RAG was not there. That's why it's giving until I train this date, and by this time I don't have any updated information. Because later the integrated RAG concept, if the information is not available, now they are going to other source, maybe internet. They're googling or they're searching in the internet and getting the information and consolidating that information and showing you. Okay, so that RAG is a concept, but we need to implement that knowledge base. Should be some majority people will use vector database to store that data in vector format, because documents text is huge. So to take semantic data and store in numbers, that way we'll use a vector database. Okay. So these external systems could be third-party applications. Okay, so we'll have a different format. We don't know. So there comes a MCP model context protocol. Okay. So with that, maybe you can integrate actions and you can remember, because external systems are the other thing, right? We can store that data. We can use variables, all the stuff in external systems, and frameworks. There are frameworks available as well. Okay. So in this thing, so generative AI. So any generative AI application is basically, it involves LLM and some RAG. Those kind of things we'll call as a generative AI applications. Any application would just involves LLM or and RAG as well. That we'll call as generative AI applications, generative AI LLM applications. Okay. If any external systems or third-party tools or modules, more flows, right? More modules involved. That will call as a agentic AI. Okay. Any questions here? So this is
So
all. Yeah.
yeah, here, so we only need to decide we need to interact with RAG or with external system, or after receiving response from the RAG, we need to go for the external system. And so how
No,
to
see,
differentiate?
yeah. So this is all business requirements covering. Okay.
Okay.
So let's say if you want to, let's say there are policy documents, there are 10,000 documents are there. Assume there are 10,000 PDFs.
Mhm.
Okay. So, but if you want to refer a security policy or leave policy, if you want to refer a leave policy,
Mhm.
okay, instead of referring those documents, where is that all the time, you can send a request from here, prompt saying that, can you provide me leave a policy? Okay, that request comes here. This LLM doesn't know about our company policy, right?
Mhm.
Then it will go to RAG and it will get the semantics from this RAG. Okay, this knowledge base, from this database, knowledge base, basically database, and that knowledge base. So this LLM will take and it consolidate that, and it will give the response.
Mhm.
Okay, so this is a high level. All this process basically, we are going to implement. First, we'll before sending to the LLM. So that's a security policy. We'll go to the RAG system, get the information, and pass it to LLM, get the response, pass it back to response.
Mhm. Okay.
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 So that is how also, if that is a policy related stuff.
Mhm.
Let's say if you want to get the, hey, give me employee details of Gauri, that also HR may ask.
Mhm. Okay.
In that time, let's say give me the the Gauri information. If HR asks that question, here LLM doesn't have a details about Gauri. So then it will go to external system. Could be they need to connect to the database. Okay. So that could be they'll have some other third party. So let's say if the Gauri is not part of, maybe if they are using some vending a third party vendor, they'll connect to that and they'll get the information, and that information will pass to LLM, and LLM will consolidate it and give you the response.
So okay, you are saying we should know when to interact with RAG and when to interact with external
Yeah,
system.
that is a flow, right? That flow we need to decide.
No.
Okay, so
Okay.
maybe customer or business requirement, they'll tell the generic problem.
Hmm.
Then we need to specify. So analyzing that, what are the modules involved it? What is the use case for that? Do we have any knowledge base? Like if you have more documents, maybe you can go for RAG. Or if you are already existing third party systems, maybe you need to connect that for that. So this thing we need to design the flow.
Okay. Okay.
Okay, so that is what agentic AI. You have multiple systems, right? We need to connect with them.
Hmm.
Yeah. So these are very high level.
Okay.
Okay, so then see, that LLM may involve multiple LLM models also. That is also valid.
Hmm.
Okay, so we have many, right? We have a Chat GPT, OpenAI model, we have Gemini model, we have Claude, all the stuff, right?
Hmm.
Maybe one model is good for Gemini, maybe another one is good for another use case.
Okay. Okay.
So you need to involve all the stuff. Multiple models also you can integrate.
Okay.
Okay.
Hmm.
Yeah. Any more questions? Right. So let's say if your company asks for, see, I have a lot of documents, and I want to use a AI based application for that. In that, it is a very common scenario. In that case, you go for a RAG. I think you can use any LLM and RAG. So, but RAG, it looks high level is simple thing. So, but basically it involves some more steps involved in that. That we'll discuss later. No, not only security. RAG, we are saying a RAG system, right? RAG system basically is having a multiple sub parts. Basically, retrieving the data, retrieving the semantics. We need to categorize, tokenize it. So all the stuff. Okay, so that is a separate process.
Okay. In RAG also we need to do some coding, Chandu.
Yeah. So because here we are saying a knowledge based documents, right?
Uh,
This document is basically it's this, so they will get a PDFs or text documents, or what the text will get.
uh.
Okay, so that text will store in the database.
Okay.
Oh, that database, a vector database. How we are going to store in the vector database? What is the content? Why we are going for vector database? All the stuff will come into picture in RAG.
Okay. 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 So, Chandu, in some Facebook, right?
Mm-hmm.
Some ads are coming like Redis database. That is a vector database.
Oh,
Right.
Redis is not a vector database. Redis is a basically cache. It's a key store, key value pair kind of thing.
Okay. Okay.
Yeah, it's normally it use it for caching or session storage. I think I discussed in
Yeah.
that
Yeah. You
concept.
discussed. Yeah.
Yeah,
Yeah.
yeah.
So.
Session based, all the stuff. Okay, yeah, that memory is very expensive.
Okay. Okay.
So this is a vector database. Yeah, I'll discuss more on that. Why you are going for vector for RAG systems, all the stuff. Yeah,
Okay.
we'll have a separate session on that.
Okay. Okay. So no need to means is it good to learn the Redis?
So sorry, your voice is low.
Is
Low.
it good to learn Redis or
No, you have to learn. So it's Redis, huh?
Redis?
So Redis is a database. So
Uh,
basically, it's a key value pair. It's kind of a dictionary.
mm,
So what you need to learn is how to integrate it. See,
mm.
where are the use cases you are going to use that?
Okay. Okay.
Okay, Redis is not a complex thing to learn. Okay, but the advantage of Redis is it's very efficient. These things you can use. So because of this Redis or Redis kind of system, Memcache is another one. Okay, you can improve the performance. Okay, you can improve the performance. That's why you need to understand in what are the scenarios where we can use this Redis,
Mhm.
so that you can improve productivity or performance. Okay, so normally all big systems or live system, they are using caching functionality. Not only banking, any application, if the response time is concerned, so they should use that one, either Redis or Memcache or some other third party.
Okay.
Okay, yeah. Let's see. Yeah, maybe instead of MCP protocol, I don't want to discuss high level, but one thing you need to understand is, sorry, it's a kind of a universal connector. Sorry, it's taking some time. 1 minute. Yeah, it acts as a universal connector. So because it seamlessly interacts with AI models, external tools, services, and data. So AI models, I told you, right? So you can connect with the multiple AI models. It's not restricted to only one model. Okay. So I'll try to compare this one. It's a universal connector, right? Let's take. So now we are using USB port, all the stuff, right? If you remember. Okay. So now a USB port we are using to connect with the multiple devices, correct? Let's say laptop. So using USB Type C, we are connecting to external hard disk, right? With the same USB type, we are connecting to monitor. We are connecting to power charger, right? So port is same, but we are connecting with the multiple external devices for the same device, laptop, right? So here, instead of laptop, you can use mobile. From mobile also, you can connect to this system, or maybe CPU. You can connect these systems, right? So here the thing is that USB Type C is a common. It's a common port, right? So you can connect into multiple devices. So similarly, for AI based system, we can that's a VS Code icon. I just showed you VS Code. So via MCP, they can connect to any remote code. That's a code. They can also connect to database. They can also connect to any, so they can send a notification, mail system, all the stuff. Okay. So either VS Code, instead of VS Code, you can replace with Claude Desktop or any Python application. See, if you take a one-to-one mapping between left and right, so here MCP is a kind of a universal connector, USB Type C. Okay, so MCP server so can interact with the external systems. See, if you see that hierarchy, so top level is a host, so it's a protocol and servers. So this host, MCP top is a host. That MCP host is internally having a, that these are the host we'll call, and these things, the Cloud, VS Code, these are clients. Python application is a client. Okay, so like this, we can connect with the external systems using a protocol. So MCP is a currently standard protocol for connecting with external systems using LLM applications. Any questions? So host, which one we are going to use? Let's say laptop is a host for you, mobile is a host for you. Right side is basically host is any application. So I for that. So it could be website, it could be mobile application, it could be IDE. Okay, where you are using that. Anything in that it internally uses that feature. Let's say in VS Code is IDE, right? In that you are writing the code, you are testing it, you are debugging it. So like that, we can also connect with the external systems using MCP. Yeah. Like that, Claude Desktop. Maybe I'll show you a demo using Claude Desktop. Okay. Yeah. Maybe instead of showing it how would this MCP works, I'll show you the demo. That will be good for you guys. So what I did, so did you heard about Claude Desktop? No, Claude. So Claude Desktop is an application. It's a desktop application. It's a kind of so like see you're using a Chat GPT, right? So where you are using Chat GPT? Browser or mobile application, right? Either browser is basically web app or mobile application, and there should be also some desktop application for web Chat GPT, but nobody is using it. So desktop application you can install in our laptop or in CPU or in your desktop, and you can use that. Okay, so like that, Claude is another LLM model. I'm using that thing, and I integrated MCP server. It's external application in this LLM. Okay, so what is that LLM application I did is it's a kind of a leave management system. I created a Python code. I wrote the Python code for a leave management system, and I integrated to one particular LLM. That's a Claude. So now we can ask questions to Claude or that LLM, and it will give you the responses. Okay, let's see. So leave management system I integrated, right? I'll show you that. So here, so I integrated leave management system. You can see that. Let's see. So how many leaves are available for Chandra? So because I integrated my third-party application, external application to this LLM, it is going to respond. Let's see. It is taking a lot of time. Normally, not take this much time. Hmm. See here, whenever I ask the question, initially that LLM checked for a common LLM model. Okay. After that, it did not find the information about this task. So that's way it is going to external system. External system I integrated. See, leave management is the application name, and in that it is trying to get a method get leave balance. You're following? Any questions here? So we integrated third-party system. Okay, so we integrated a third-party system of leave management. So LLM is a generic model. It's kind of a public model. Claude is a public model, public LLM. It doesn't have a leave management system of my leave management system. So I integrated leave management system with the LLM. So initially it checks in LLM that information is not available. Then it is going to my integrated third-party system, leave management here.
So for this, you are using MCP.
Yeah, so I used MCP. I integrated MCP to the Claude model.
Okay, from Claude, you are calling the MCP server.
Right.
Your database MCP server.
Right. If you compare that picture, right? First request comes to LLM model, from LLM model to external system via MCP. Okay. So now instead of hello always, I'm using hello one just to understand. I'm giving a permission. So now see, Chandra has 15 days of leaves available. I got the response. Right? Now, any questions here? Now I can say apply 2 days leaves for him on the occasion of Dasara. On the occasion, maybe. Yeah, that is the advantage of LLM. That's why we are using LLM. Otherwise, you can directly use external machine system, right? So all this consolidates it. Now, see, anyway, it is asking here, but because I'm saying hello once, otherwise, if you do hello always, it will give. But for a demo purpose, I'm clicking like that. See, so here, if you see, I did not specify apply leave for Chandra. I said apply 2 leaves for him. Him. So it consider because it remembers the history, memory related thing what we discussed in the first session, right? So this is the information it is storing, remembering the information, and it. Yeah, everything it will remember. See, leave has been successfully applied for Chandra. So 2 days of leave has been approved when there's an order for Dasara occasion. The leave ID is this one, and Chandra leave balance will now be reduced to 13. Okay, 15 to 13. Right? See, because see which one looks good. Normally for HR team, so this is going to be helpful, right? Sorry. Right. Okay. That's a good question. So here, so whatever the application I did, I try to make it more simplified. Okay. So if you want for applies, the apply is a API Python function. Let's go to the code now. So now we'll get that thing. In leave, see if you see apply leave is a method, Python method. Okay. Apply leave is a Python method. It basically takes employee name, number of days, and the reason. So it is not expecting date details. It's just taking number of days. If you want to take a dates also, you need to modify this method. That is all a logic here. That is all external system, right? You can write whatever you want. Guys, you are following or still not clear?
Yes, Chandra. Clear.
Gauri, Shiva.
Yeah.
Okay. Right. So let's say, so if you want to add, get me leave details of Anand. I'll take one more thing. Okay, you get me leave details of. It's trying to get the leave history. That leave history is a method name here. See, leave history is a method name here. This is the logic we have added. So getting the leave details basically it connects to the database. This is like our API, right? We already implemented fast API code. You guys are recollecting?
Yeah.
Yeah, so once you are hitting this one, this is all in our control. MCE is to make the connection between LLM or LLM host and the external system. Once you are connected to the external system, that is a normal regular functionality only. Okay. So let's see what is a response for this one. So leave management, I am saying hello once. See, this is the advantage of LLM. If you see, let's say if you search for Anand, it is clearly giving the more details. It looks like Anand is not found in the employee system. This could mean Anand has not been added. The name might be misspelled. Okay, that's fine. And it is also asking, would you want to add Anand as a new employee? Okay. So this is the advantage with LLM. If you use a web applications or any mobile application, if you search for Anand, it just gives a not found, right? So this will give a more descriptive way, and it is giving a proactively. It's asking you. So if you want to add more things, it's giving the suggestions. Okay. So then I'll say yes, yes, add. Let's take what will happen.
Service.
So I'm saying S add, no, nothing I did, S add, or maybe if you do S also, it will proceed. So it is going to add a new employee, Anand. So it is calling a add employee method that is there in Python. There is an add employee method. Okay, so let's see here. See, Anand has been successfully added as a new employee. Default leave balance is 10 days because whenever new employee is added, default number of leaves are 10. So you got the point? Yeah, any questions here? This is how we are going to develop applications, LLM applications. So here we did not use any training stuff or so ML models, all the things. No, we are not using that. So our goal is to build systems using LLMs. Okay, so how we are going to build system basing on requirement, which model we need to use, which system we need to build, how to integrate, how to connect between systems. This is what we are going to do. So that's why initially I started regarding APIs. If you understand APIs and connecting between systems easily, so LLM developing LLM application is going to be very easy for you. Okay, so here we just did the integrate. We integrated backend system. That backend system is basically API server. Sorry, MCP server. Okay, so nowadays all technologies, Python, Node.js, Java, all are giving inbuilt MCP servers. You no need to develop new MCP servers. But so using MCP server, you create your things and you create a LLM applications. Those will call as a AI based systems. Okay, any questions here? So now
No,
let's
sir.
go. Let's go to the slide. So whatever we did, right? Let's take the high level thing. We are asking a question to MCP host. That MCP host here is a Claude Desktop. We can use a VS Code, a Python application, anything. How it will work is we are prompting as a question. So first it will go to the tools, get tools using MCP server. Okay, so that tools may be from the database, maybe from source code, maybe from email notification or files, whatever it is. Okay, so here in this case we got tools, basically names, right? Apply leave, get leave history, those are available here in the leave management system. If you see the leave management system, it's having say get leave history, apply leave, get leave balance, add employee. These are the method names I added in Python function, sorry, Python file that integrated to Claude. So we got it here. Okay. And once we get the tools, it will ask question plus tools. What the question plus tools to LLM, basing on tools and the question, it will understand and it will suggest a it will suggest a tool because it's having a number of tools, because tools is a multiple thing, right? It's a plural. So basing on the tools, like tools here we have 5 methods. From those 5 methods it will suggest, let's say, apply leave. Okay, maybe it's calling apply underscore leave method, adding a new employee. So add underscore the employee. So that it will suggest, and that tool, basically that method, it will send to MCP server. From that MCP server, we'll get the response. That response will pass it back to as an answer. Okay, so this is how high level MCP works. Any questions here? The tools is here in this case. Tools means methods in our MCP code that I showed you here, right? Here we are specifying here the tool. So this is a tool, MCP tool. This method is a tool. This is another tool. This is another tool, like that. Okay. Yeah, basically, so MCP capabilities, if you take any MCP server, normally the capabilities are tools, resources, and prompt. So tools is the main thing. So most of the MCP servers is having tools. So that's the only majority, 99% all MCP servers mostly use tools. Okay. So basically, actions are functions. Function call made by AI agent. In this case, it's a Claude Desktop. Okay, so we have an API, so maybe that method to get the available features. Tools / list will give the available tools. Like that, we have the resources. Resources, basically it's for read-only data. So mostly documents, DB schemas, file content, all the stuff. But the majority is basically tools. MCP server is a tools. Okay. Any questions here? Yeah, if you compare with MCP and API, it's most similarly. So architecture is client server. Purpose is API is general purpose, but MCP is only supports LLM applications. So API is a stateless, no memory, so whereas MCP is stateful, retains memory, and it gives the context as well. Okay. So a dynamic self-discovery, this is the one of the advantage of MCP. So in APIs, right, if there any update, like let's say if you update a API version or any response format, we need to change the code in the client side, correct? So whereas in MCP side, so you no need to modify the client code because we have a tool/list is API, right? It will provide all the available services. Okay. Yeah. So any questions here? Okay. Then I'll stop here for today. So no, it's a kind of, let's take API. Let's say you are using one API version 1.0. Okay, so if that API got updated to 2.0, then you need to change that in your client side because API endpoint got changed, right? So if you are making any client side change, obviously we need to deploy, right? If you are making any new change, you need to deploy, right? So that will so in this case, because we are getting a available list, based on list only we are taking. So the code is common for all the stuff. Okay. Yeah. Any more questions? Okay. So maybe we'll connect on Wednesday then. Thanks.